Hey guys, welcome to this pretty lengthy tutorial for our third-person shooter where we start with networking code. But before we start, let's take a look at what we will be doing in this first part. Starting the host here and client here. Now what you can see is that our player is synchronized and the animations are synchronized. We can shoot. The only thing we are not doing, I was just seeing that, is that we have not we are not syncing the aiming animation, but I think you can manage to do that yourself. We have client-side prediction enabled, so if we are missing out on synchronizations or anything, then it can be corrected. It will be corrected. We have the host who can move around and play. Well, yeah, that's it. Let's quickly get started, and I hope you like it. So let's get started by adding an empty game object for our network manager. We are going to use, let's put this at 0. We are going to use the network manager from Unity. It's fairly easy to change this to Photon or whatever network library you want to use, but we're going to use the network manager and the network manager HUD while we are working on synchronizing our player, because it's convenient. So open up the spawn info. This is where we can add a player prefab, but the player prefab requires the network identity. So make a prefab for your player if you haven't done so already by dragging it to the prefab folder. And after that, rename our player to player network. And let's add an network identity, which is required to synchronize or to communicate with the server. Now also create a prefab out of the player network. Now if we go to the network manager, let's drag in the prefab and let's disable it here in the game. Now also when you want to build, make sure you uncheck the main menu so we can always start here, because the most difficult part here is that we have to keep on trying everything, because it takes a lot of time to debug everything. So maybe it's so we always want to start in the level here. And what you also can do, if you want, if your PC is a little bit slow on compiling the lightning, you can uncheck the auto generate here, so then it will be always dark in your level, but then you don't need any time to compile when you want to compile the game. Alright, with that said, we are going to run into a lot of problems if we are going to start this. So let's see. If we now run the game, we get this HUD here, then we press host, then absolutely nothing seems to happen. That's because it was disabled. I'm sorry. You need to I'm sorry, let's drag in the play network here to the, whoops, stop messing around, from here, and make sure it's enabled when you apply it, because otherwise it will be disabled in the from the prefab. So when you spawn, it will be disabled. Yeah, so let's press host, and now it goes here. Okay, well, it works, but you can see there's some errors here coming, so we probably need to fix that. And let's also create a new let's build, and if you press Control B, it will automatically build your game and start up the game. So let's hit play on this one, and let's hit play here too. We're gonna host on the over here, and we press client over here. Now then you can see everything is going wrong because the camera doesn't, whoops, the camera doesn't know and the game doesn't know who is who, so it's not synchronizing, it's just controlling all the players, which is obviously not what we want to do. So what we need to do is we need to change stuff around, and we need to change stuff around quite bad. Let's start with the small fixes. Let's open up the Crosshair script because that's the one where we have the first error, and then it basically says we have not assigned the reticule. Well, that's correct, because if you look at our player, I'm sorry, at the canvas, we have our reticule. I'm sorry, no. Of course, in the player, we have our reticule here, which is assigned, which was assigned by dragging it in. Now, we only want to have the reticule or the crosshair when we are the local player, and with local player, I mean the absolute network local player. So I don't want to throw in a bunch of network identities all over so that we can communicate or get everything. I just want one simple script to control everything for our player. So what we're going to do, we are going to make a few changes. Let's start with the changes in the network in the game manager. So let's open that one up. What we want to do, we want to know if we are a network game. Now, instead of adding a network identity to this one as well, we are going to make a new reference. Let's make a private bool m is a network game, and another one is network game checked, or something like that. Then if we are making a property, then we will make a property here in our which is a boolean, it's network game, which is a getter only, and if not m network is checked. So if we haven't checked already, we are going to first say is network checked is true. So we checked for the network, and then we're going to say m is network game equals to game object find, and then we are going to search for the network manager if this is not null, if this is null. So then we can say return the m is network game. Yeah, so if we are going to call this one, we are checking for this game object. If it exists, then we are assuming it's a network game, or then it is a network game. So that's the first thing. And now let's go to the player. Maybe in the awake method, we are now getting the input from the game manager, and we set in the local player and stuff. We are going to change that. So let's make let's press Ctrl R and M to make a new method here, and let's call this set as local. Whoops, as local player. Didn't work the way I wanted it, but that's okay. Now we only want to do this if the game manager instance is network game. I mark this public, of course, otherwise I cannot reach it from here. Is network game. So if we are not playing a network game, we are going to set ourselves as the local player. So this will avoid doing this when we are, well, I mean, if we are running a single player game, it will do this. If this is not a single player game, like it's a multiplayer game, we are going to set this somewhere else. Let's create a new script for our network. So let's go to the scripts player, and let's call this player network, and we're gonna assign this to the prefab. This is an old one, as you can see. I don't need this. So I've assigned it here, player network. Let's also check the local player authority, so that we are basically telling this object is controlled by a local player. Open it up. Now in our player network, we want to get rid of this. This is where we will say we are having a network. This is a network behavior, and we need the Unity engine networking namespace for it, so that we have access to the isLocal and stuff from the network behavior. Yeah, so in the start, we are first going to set the isLocal player. So we need a reference to the player. So player, and in the start we say player get component player. Now, of course, we always require the component of player when we add this to some object. And then we can say if isLocal player, we are going to say player. We also need this one public. This is private right now. Then we are going to set this value. I'm sorry, the property set as local player from our network script. All right. So now this only gets called if we are the local player. So we are not. Well, right now we are still controlling everything, but we don't want to control everything from the other player, so we will change that. Okay, let's see. Then we have the problem with our Crosshair script. So let's open up the Crosshair. Because what happens when the player spawns in, it will check for the it will attach this to the we have assigned the reticule from the inspector, but when you spawn a network game, a network prefab, we don't have that reference, so we want to assign it here. But we also want to have this working the same way we have right now. If we are get component, let's say the parent, player is network. Yeah, we need a reference to a local player in our player. So let's go back to a player. Let's make a variable here. Let's call this public bool is local player. And then we are going to assign this in our method here, which we just created. Is local player true. So if we now switch back to our Crosshair, we can say if our player is the local player. If we are not the local player, we are simply going to destroy this game object, because we don't need a reticule for the clients. Okay, so let's see if that fixes it a little bit. If we run, what did I forget? Let's first disable the enemy players too, as we don't want them. There we go. Okay, one error is fixed, but others have occurred, it seems. Let's take a look at the crosshair. Oh, it didn't find any crosshairs radicals right now. Because now we need to assign the radical here. So if we are returning, we are the client and otherwise our remote client, and otherwise we want to say radical equals to the game object find, I believe it was canvas radical, and we want to transform for it. Okay, so you need to make sure that this path is correct to your canvas. Run again. Okay, well, we cleared those errors now, so that's the first thing. Let's also run it again. We are still not controlling correctly, but just want to make sure that we don't get any mistakes now. I'm gonna host it here. Right. So as you can see, we are still controlling the other player, but we're also getting a new error. So let's see what that error gives us. Mouse input. So for the look around, let's see if we are the player. We only want to look around if we are the local player. So then we can simply say if is local player, look around. So this should fix that error. Let's give that another try. Now, like I said, this is what will cost you the most of the time, is that if you are running the trying to debug everything. So we host here, and it's not rotating it. This is black because I was building this before it was finished baking the lights. But okay, this is fair enough. So what we need to do now is we need to synchronize. Now we could add the network transform thingy and synchronize it, but that's absolutely no fun. So we are not going to do it. We are going to make our changes in our player network code. And what we want to do is we want to, of course, predict our state so we don't experience any lag. We will add that later on. But instead of, we don't want to send our positions right away, because that exposes cheating an easy way, because it's fairly easy to alter the packages. So what we are going to do, we are going to create a network state, and we are synchronizing those network states to the clients, to the server, and then we are going to synchronize the result of the state to all the other clients. Or we just pass on the network state itself, and then we make corrections if the positions don't match up, because the physics engine isn't the same on every client. So on my local client, the result of a movement can be slightly different than the server. So what we're going to do, we're going to send our inputs, move on the server, and then send our inputs back along with the result. And if the results are close enough, we are going to ignore it. And if it's too far away, we're going to move or lerp our player towards that location to keep it in sync. Okay, so let's create a network state which we can synchronize over the network. But before we do that, we are going to head over to our input controller, because we need to change a lot of things on that as well. So input controller. There it is. Because we are going to synchronize these states along with something else, we are going to make a public class input state, and then we are going to put these values for vertical, horizontal. We don't do the mouse input, but we are going to do the fire one, reload, walking, sprinting, crouched, mouse wheel up. Also, we won't synchronize that one. Cover toggle, probably not. Yeah, this one as well. And then we want to also add these is walking, is sprinting, is crouched, cover toggle, aim angle, and is aiming booleans, which we can use for the animation. And then we are going to change the variables here because we got a lot of reference to the. Then we're gonna say get, and we're gonna return the state. So we are making a public state. Whoops. Input state. We can make this public because we are making this public. We can do it right this way. And in a start method, which we don't have, we are going to say state equals to a new state, input state, which is basically an instance of the input state. So if we are here, we're gonna get, and then we're gonna return the state vertical. Yeah, we're gonna do the same for horizontal, fire one, fire two, reload, is walking, sprinting, crouched, and the cover toggle. So horizontal, fire one, fire two, reload is walking. This is just some tedious work we need to do. Is crouched and cover toggle. Now match these properties. This should be bools. Reload also. I'm just copying that over because the names do match, and you can see it has all kinds of references already. So we fixed those references right away. Then we have our mouse input, which will be local. Escape will be local, and mouse will up and down too. Okay, now we need to fix this. So we add the update will be state. We don't need to have a state for that. Let's separate this so it's more clear what we are having in the state and whatnot. Okay, we still have the is aiming, but we are going to change it, change this somewhere else. Okay, sorry. Yeah. So let's head back to the player network, and then we are going to create our own states, which we are going to synchronize. So we're going to make a public partial class network state. This will inherit from the input controller input state. Yeah. What this basically means, a partial class, is that we have, if we are going to add properties here, like public float X or whatever. When we use this, we have access to these properties here and to the properties which we are going to add here. So you basically are extending the class. So what we're going to do here, we are going to make we are going to synchronize these states, but we are going to sync the inputs, but we also want to get some references back. So let's make public float position X, which will be like the solution on the server of our movement. Z, and we also want to have the rotation of our player. Let's also add the timestamp, because what we are going to do, we are let's see, how can I explain this? Maybe like this, a little bit drawing with my mouse, so it will be very very ugly. What we are going to do real quick, if this is a timeline, I hope this won't make it any worse by explaining it like this, but this is the time, whoops, this is a time. Let's say this is the client, this is the server on this part. So if we are on the client, we are going to press up. We are then also moving our player to a different location, X and Y. We are going to add the timestamp, let's call this T, to our input. Yeah. So the result here, I'm sorry, this is what we are going to send a network state to the server. When it reaches the server, it will be a little later, because it will take some time. So we receive the input and we have a time from it. Now then we are going to move our player on the server. Let's say the result gets here. Yeah, we are still a little bit lagging behind the client, but we still have the time which we received from the input. So then we are basically going to send that back to the client, and then we are going to compare the times. So if these times and these results are pretty much so we are going to look for if an input state which was equal on the time, and then we are going to compare the X and Y results. If they are the same, we are saying, well, it was fine, so you can keep on moving. If they differ too much, we're gonna move the player back to that location. Yeah, I hope you don't feel any dumber looking at this picture here, but that's the way it's going to work. All right. Let's see. So that is our position X and Y, and a timestamp and a rotation. So everything will be wrapped around that. So first, when we need to know if we are the local player, which we are controlling. So then we're going to collect the input. So let's create a private network state. Collect input. So we only want to collect the input for the local player. So let's call it var state equals to new network state. And then we are simply going to add in all the variables. This will be game manager, instance, input controller, cover toggle. The next one, press Control Space, aim angle. We cannot use it here. Fire 1. Let's make a copy here so it will be a little bit faster. Fire 1, fire 2. Then we get the horizontal. is crouched. Is aiming will be set somewhere later, probably. So is sprinting. Is sprinting. Is walking. Well, then we get the position X, Y, Z, but that's not our input, so we are not going to collect this. We are going to collect reload, and the rotation angle will be our transforms rotation Euler. I think it's Euler or Euler, I'm not really sure why. So we simply get the rotation, and then we're going to add a timestamp to it. Yeah. So then we're going to return the state, something like this. Now, in our update method, we are first going to check if we are the local player. And remind you, this is the network behavior local player. Yeah? So this is the one who has authority over the game object where this script is run. I'm pointing with my finger, which you obviously don't see. But so now we need a state. Let's create a variable for it, which we can, which you can use. Network state. Let's make sure it's not null when we start, so it's a new network state. And it's going to be difficult later on, because then we are this same script is used on the remote client, on the server, on the local player, and so you need to make sure that that you understand the principle. But it will be I hopefully can explain that later on when we move further. So now we are collecting the input in our update. So then we can say if we are the local player, we're gonna say state equals to collect input. And then we want to move our player, because in a network player we only want to move our player from the network controller. So we need to disable everything which relates to moving in the other scripts. Let's see, it will be the player move, play move base. Something I tried, I think. Let's see. So if we are moving, let's see. Let's add a new move method here, which takes in the horizontal input and a vertical input. And let's see, then we are going to do this part. But instead of taking the player input, we are going to say it's the vertical from the variable and the horizontal. Okay. We can keep these settings here. Now let's make a new, we can still have a reference here to the move, only one, which is from this script as well, from the update method here. So what we are then going to do, we are going to make an input state here. So instead of using the player input controller, we are going to use an input state. And let's see, instead of the input controller, we're going to say input controller input state. And obviously this will fail now, so this will be the input controller state as well. And then we have our move. So then we can say player input equals to game manager instance input controller state. We need to make sure that the player input is something, because it can be null when the player spawns. So if we say if player input equals to false, sorry, null, we want to do this part. Oops. And then we're going to say if player input equals to null, return. So we make sure we have a state before we continue this part. Otherwise we will say move player input, and then we pass in the horizontal and the player input vertical, which now come from the state. Yeah, so this is still pretty much the same we had previously. However, we can now change the input controller state more easy. So if we are awaking, we are simply getting the state from the game manager. But now we are going to add a new method, so we can add the state, or we can change the state. So let's make a public method here, public void set input controller, or maybe it should be input state, input controller state, and then we're gonna say player input equals to the state. Yeah, so now we can change the input controller from a different script. Now in the update method, we don't always want to move, because if we are not the player, a local player, we want to return. So if we are not the local player, we're not updating here at all. If we are the local player, we want to make sure that if the game manager instance is network game, we want to move. So we only want to move in a non-network game. Let's give this a test. If we let's drag in the prefab for the normal player and disable the game manager, the network manager, and then we see it moves, but we lose some we lose the animation, so we need to change that. Let's drag this here just to get a better view of our player. Yeah, so we still need to fix the animations, because that changed to the input state, of course. So let's open up the animation for the player. We are still getting the references here from the input controller, which we have changed. So let's see. We want to get the local player input here. So get local player input, and then we are going to say these values here, which we use. Let's make this public. Maybe you don't even need them public. Vertical, horizontal is walking, is sprinting, is crouched, float, aim angle, is aiming. Of course, these are booleans. Then we have this aiming. Then we have the bool is in cover. I think this is pretty much it. Yeah. So then we are going to assign these values, which we did here. So we have the vertical, which is this part, and also horizontal. This isn't, of course, the game manager anymore. This should be the state of the player. So let's get a private pool, private player, get fm we are in the player animation, so we can say get component player, like this, and then we can say here player. Now we need the state, of course, so let's go to the player, and then we need to have a reference to our player state. So let's do this the same way. Player state. Copy a bunch of things over to make that working. Of course, this will be oh, I'm sorry, this is the player state we have here. This should be the input state. I'm sorry, input controller state, input state, input state, and we want to get the input state here, and this should of course be the game manager instance input controller state. Oops. So like this. Back to the animation, then we can say player, then we have the input state vertical, and for the player input state horizontal, input state, copy this part here, horizontal, and let's see, we also need the walking, which will be the game manager instance local player state. Let's see how it was it here. This part, this hasn't changed, I think. We'll see. Is sprinting. Let's take the same part here. Or maybe better take it from the player input state. Sprinting is crouched. The aim angle, our method is player aim get angle, just like we do down here. And we have the is aiming equals to this part. And our is in cover was also the same part here. And now in our update method, let's make sure we have everything. Horizontal, vertical, walking, sprinting, crouched, aim angle is aiming, is in cover. Yeah, so that's everything. So in our update, let's first say if our player is local player, get local player input. So we collect the input from the local player, and then we say vertical equals to the vertical. We should be yeah, we could also just simply ignore this method and get these states here, I think. But let's do it like this first. Let's see where it ends up. This should be is walking, is sprinting, is crouched, aim angle, is aiming, and the last one is in cover. Okay, so we do this so that we are able to change when we change the when we change the input state of the player, this component is attached to, we can update the parameters for the animator. So let's see if this still works the way it was before. There we go. So we can still do everything. Yep, that works. Now let's enable the network manager and disable the player. And if we host, nothing happens. That's correct, because we are not moving from our player network. Remember, in our update method for the player move, we disable moving if we are a network game. So now we're here. We have collected the back to the player network. We have collected the input, and then we can say, or then we should say, player move set. Oh, we don't have a reference here. Do we have a move in the player? No, so let's get a reference to it. Player move. And of course, in the start method, we need a reference to it. Let's also get the animator, because I know we are going to use it. Player animation, player animation. Then we say player move equals to get component player move, player animation, anim. Okay. So now we can say player move, and now we have the move method. I'm sorry, we don't want to set the move method. We would just want to first set the input controller to our current state. Now, this only sets the input controller. It doesn't move anymore, so we need to move this here too. So then we can say here player move, and then we say the state horizontal, state vertical. Yeah. So let's see what happens. We host, absolutely nothing happens. There we go. It moves, but not the way we want. I'll probably switch things around too. Yeah, horizontal, vertically. Did I do it correctly here? Horizontal. I didn't do the vertical. Is this enough? Note that when we are not entirely, but we are also spawning inside the wall, so I'm gonna move this wall a little bit. Let's see, we are still doing something wrong. if we collect the input, it's the horizontal and the vertical. Yeah, then we move horizontal and vertical. Vertical times the move speed, horizontal times the move speed. Let's print the direction here. Let's I mean, forward doesn't do. It's updating wrong positions, I think. Are these the same? I think they are the same. Ah, stupid. Both the probably already fixed it when we did this. Let's see again. There we go. Okay, so still no networking in progress, but we are moving. Let's get rid of this print here. So now we are moving. If we are a server, we can probably, let's build and compile by pressing Ctrl B. And then we are going to run this. And we're also going to run on the server. I mean, this will be the host. Move. The positions are immediately updated when you spawn in. But obviously this is not synchronized, yeah, because we are not sending anything at all. But we can move, we can shoot on if we are the client or the server. So that's a good start, I think. Alright, so now we are ready to synchronize our states to the server, and we are going to do this in our fixed update. So in the fixed update method of our play network, we're first going to check if we are the local player. Doesn't matter if we are the server or not. We want to see if our state is different from our previous state. So we need a way to check our states. So we have our state here, but we also need like a last send state, which is the state we transmitted. And then we can check if these are, let's call this marked dirty. So if it has changed, we say it's dirty. So is input state dirty, which takes in a network state. Let's call this A, network state B. And then we say if B equals to null, we always say true. So if we didn't have a state before, which we are comparing, we say it's dirty. Now otherwise we're going to say return, and we're going to compare the values we want to compare if we want to update the state and transmit it to the server. So if we return aim angle not equals to B aim angle, or, and then we can just simply continue for the cover toggle. Let's also add the fire one. So basically, if we are holding the fire buttons for a long time, we are only updating the first time we pressed it, and otherwise we just keep on. Also for moving, even better example, if we move horizontally or vertically, we are only updating if this has if it has changed since the last update. If it doesn't, we just keep repeating the last state we have received. Yeah, so let's add the vertical here, and also let's see what would we have more. Is aiming to toggle the animations. It's crouched. Maybe it's faster to do one side before. Sprinting, just don't forget it. Walking. Reload. And of course, our rotation angle. You could also add in like you only want to update the rotation if a minimum amount has changed or something like that. Okay, make sure we are comparing the right values here. Yep. Okay, so this will return false if they are all the same, and it will return true if either one of these is not the same. So in our fixed update again, we are going to check for this state if is input state dirty, and then we get the state and the last send state. Then we're going to say last send state equals to our current state, and then we want to tell the server the state, and we are going to use commands and RPCs for that. So let's make a void command handle input. This will take a byte array of data. Now I'm aware this is not the fastest way to send data over, but this will work for this example for now. So the command is run on the server. Yeah. So when the client calls a command, it get executed on the server. Same goes for RPCs. Let's call this client RPC. We're not calling. We decorating it with a client RPC attribute, which is required. RPC handle state solution, which is also a byte array of data. Yeah. So in order for this to work, the method needs to be called RPC when you decorate it with a client RPC, and it needs to be CMD if you want it to be a command. Yeah, that's important, otherwise it won't work. And now we need to make a new state. Let's call this last received state. Now also remember, this will be different for all the classes, all the different instances. I mean, for a remote player, it will be different than for a local player as it was for a server. Yeah, so if we are handling the input, we're going to say last received state, and we need to serialize and deserialize the data, the states we are resending. So let's move it all the way down here. Let's make a private binary formatter. And I'm aware this isn't the fastest way. There we go, but it works. Private byte array, serialize state, which takes in the state. Player, what was input state? Player state. State. So this converts the state to a byte array. So then we say using memory stream requires system IO stream equals to a new memory stream. We are using because it disposes when we end the using statement. Then we're going to say we have serialize the stream with our state. Does this accepted? Yeah. Then we return the stream to array, which is our byte array. Yeah. Now we also need to turn this around. We could also say T here, I think. Well, the only thing we are serializing is the state. So let's take a player state. And then we say deserialize state. Okay, so this takes in a byte array. Let's call this bytes. And then let's using memory stream. Stream is new memory stream from the bytes. Now we return the player state. We need to cast this to BF deserialize stream. Okay, so with these two methods in place, let me quickly try to explain a little bit. You cannot simply send over anything except if it's primitive. Like primitives for in this case would be the floats, strings, integers, bools, and such. You cannot serialize. I mean, it cannot serialize a factor 3, or for instance, and that's why we are making them floats. But if we are going to bring in an entire complex class like the network states, we can always get the bytes from it and send that over. So we can then serialize and deserialize it after we have received it. So before we receive it, we convert it to bytes, then we transmit it, and we are going to deserialize it back to what it was, a player state. So that's how it works. This takes some time, and like I said, it can be a little bit faster, but for this situation, it's in this case, it's pretty workable. Okay, so back to the command. So the command is run on the server. So the let's see, the local player sends it to the server. Local player could be a local player server. I mean, the one hosting the game. So then we simply going to say that the last received state, which is an array of, I'm sorry, a byte array. So we need to deserialize that. So we say deserialize, not deserialize, state, and it takes the bytes. So the date data. There we go. Network state, player state. This is wrong, sorry. This should be network state. There we go. So the last received state, in this case on the server, is what we have received. Yeah. Now, if we go back to the fixed update, we are now saying if the input state is dirty, we are going to set the last send state on our player, and then we're going to say command handle input, and then we serialize the state of last send state, which we just assigned here. Now, let's see. Oh, I'm again taking the wrong state here. This should be network state. Yeah. So this get then transferred from the server to the, I'm sorry, from the client to the server, or if we are the host, we get it transmitted to ourselves. And now we can see our movement. I mean, we have received the network state on the server. So if we go back to the update right here, we should check if we have a last received state. We're gonna say we're just gonna kick out. We haven't received any states for this player object, so we cancel out. We return a method. Otherwise, we want to update state. So let's make a new method. void update state. And what we are going to do, we are going to set the variables based on the last receive state. So let's, for instance, simply start with our player animation. Let's get a reference. So we say player animation, for instance, the vertical. Let's see. Player animation. We should make them public. Let's see. Yeah, we should make them public, otherwise we cannot change these. There we go. So now they are marked public. And now in our update state, player animation vertical equals to last received state vertical. And also do it for the horizontal. Let's make a few more. I believe we have is walking, is sprinting, is crouched, is aiming, is in cover, and let's see, aim angle. Now these are small letters. I'm going to change this because they are public. Then I always start with a capital. But I'm basically doing uppercase, Shift Alt F10, and then rename it. Yeah. Okay. Now the is walking should be last received state is walking, is sprinting, is crouched, is aiming, is in cover. Oh, we haven't assigned the is in cover, it seems. No. Not in a network state either. So then we should open up the input state. And we have here is in cover. And now here as well in our collect input is in cover. I don't really think we are going to use it this way. Probably not. So I'm gonna skip it out here and do it like so. So now we have the animations over. But now what will happen? I will let you show. I'll show you first what happens now if this works. Getting an error here. Not really sure what the mistake is. Let's build it one more time. Okay, now it built it. So play. We press host on this one. Ah, yeah, look. We have it marked the network state as serializable. So we first need to serialize it. Or mark it serializable. So that should be an attribute here, system.serializable. So now we tell it that it can be serialized. Yep. Control, what was it? Shift, Control B. And play. Now we probably need to mark the input state here as serializable too. Yeah, because we are of course inheriting from it. So let's mark this serializable too. Control B. Strange. Build and run. Alright, now let's move in the client. Now let's take a look at the server here. Nothing get transferred over. Okay. Not sure why. Last received state. Ah, yeah. Of course, we need to say update state. So, like I said, it's very time consuming to make a small change, then build it, run in two editor instances, of in one instance here and then an instance on the editor. And actually, to make sure you're doing it right, you also need to add another standalone for the remote client. Yeah. Okay, let's try it again. There we go. Now it won't move, but as you can see, the server receives the horizontal and vertical inputs and docking and such. The other way around, it won't. It will not show it because we are only. We are only sending it to the server. Yeah, because this is the host receiving the commands. Basically, this one, the last one, is the remote client. This is the local player, as you can see. So if we are moving, the command gets executed on this instance and will change the input controller and set the animations. Okay, so that's one thing. So we are sending over the animation states. Next thing we want to move over is our position. So what we are going to do when we are on the server, we are going to move the player. Now, except, if we are not the local player, we are going to move. So, because we don't want to move again when we receive something from the server. So then we say player move, set input controller, which is the last received state. Then we say player set input state. Oh, we don't have the input state yet here. So we are in the player, we make a new method to set the input state. Let's see. We have the input state here. So we cannot really set it. So we have a new method. Let's make a new method. Public void set input state, which is the input controller state, input state. So we can say m input state equals to state. Yeah. This is only a getter. So we change this value so it will return the input state. So we then say set input state. Basically we should set the input state only and maybe let the player move get the input state from this one. Yeah, because we are doing the same, but for now let's keep it like this. So then we could now move our player. Let's see, so then we say player move last received state horizontal, last received state vertical. Of course we also need to do the rotation but this is fair enough. Okay, so now let's see what happens. Again, host here. Remember, we don't synchronize rotation, but it moves. And you hear double sounds, of course, now. But you can see that the player moves horizontally and vertically. It's a little bit laggy on the host side because it's not that quick laptop I'm working on. So we get those received on the server. What we don't get to receive is the change of the position on the server because we are not updating the clients yet, which is what we are going to do now. Basically, we now want to send the RPC, let's see, from the fixed update. Yeah, so if we are, let's see, if the RD server and our last receive state not equals null. So this is only run maybe if we are the server, update the remote client. And again, we first get the network state. Let's call this state solution, which is a new network state. And then we're gonna say position X. So this is the one we get from our partial class. Will be our transforms position X, because we have moved. If we are the server and we have received the state, we have moved to a new position. So basically, we are going to tell the other clients what was the solution of this movement, yeah, which was a new position, for instance, of probably. And we in the same way we are passing out, will pass through the others, like for the animation. So we need the horizontal will be last received state horizontal. Let's see, vertical last received state vertical, aim angle, cover toggle, fire 1, fire 2 is aiming. I hope you are still following me here. And if you're not, you can always contact me in the comments or maybe by email if you're really stuck. Remember, it's date of recording is in 2017, so if we are in like 2027, don't bother, I guess. Rotation angle, which we don't alter yet, and of course the timestamp of our last received state. You know, like in that difficult picture I created. So now we are going to compare the state solution if it's dirty. So is input state dirty, then we going to compare the state solution with our last send state, and then we say last send state is the state solution, and then we are going to call the RPC, which gets executed on all clients on the instance of the player, and we're gonna serialize the state, this one, and passing the last send state. There we go. So now the server calls this one, and this gets executed on the remote clients again. So on the remote clients, we're gonna use the same last received state as we use on the server, but it's basically actually something totally different. Yeah. So the serialized state, it's the same thing as this, but then we have received a last received state, and then on the remote clients, the update is also running. The last received state is set, so it will update the state. So let's also add the rotation now to the remote players. Now we want to apply the rotation always before we move, so we will always move in the last known rotated direction. So let's say transforms rotation equals to quaternion Euler transform rotation Euler angles x. Let's copy this over. And we rotate only on the y-axis based on the last received state, rotation angle y, and the z-axis, so then it rotates. And basically we are the remote clients, we are basing the same, we're basically using the same way to move everything as we would move our player. However, it could be that we are out of sync a little bit. So what we're going to do, that if we are not the server, we want to check the solution from the server, how much it's different from our location, and otherwise snap to that position or move to that position. So let's get the solution here. Let's set it here. So factor 3 solution. This is our new factor 3. Pass in the last received state x, last received y, last received z. So this is the outcome of the server. Yeah. And then we say float position difference from server equals to factor 3 distance, and we pass in the transforms position and we compare it with the server position. Yeah, let's see, server position should be this is for solution, of course, like this. And then we simply going to use some value to check if it's further away. So if position from different server is like larger than 0.3, so if we are 30 centimeters wrong, we are going to lerp to that location. Position equals to factor 3 lerp transforms current position towards the solution based on our setting speed or something, spectron speed times delta time. So it's fast enough to move to that location. I don't think you will even notice this at all. Here's a small mistake. Instead of the rotation angle y, we should say here position y, of course. All right. So let's see. This will give a problem because if we are imagine we are the server and the local player, so we are hosting the game. We are setting the last send state here. If that's if the input state is 30 compared to the last send state. Now then, after that, if we are the server, so only if this is occurring on the server, we are going to send RPCs if these solutions are 30. But if we are the host, in this case, we are immediately using the last send state, which will mark this one won't never mark the last send state dirty, because it will always be the same. So we are going to introduce a new network state here, last sent RPC state maybe. So this is a server only, and basically we are going to change this last sent RPC last sent state to last sent RPC state, like this. I think we are, well, let's give it a shot and see what happens. So we compile, build, Control B, and then we hit play. Now I'm gonna host here, move forward, and the client. Well, it appears on the server. Now let's move the server, and then you can see it moves on the client too. We have the double sound, something we can fix later on, but it does what we want to do. Let's fire up another instance. I mean, I'm sure it's going to be laggy on my PC, but we want to check out if this is going to work. So here goes another one. Also a client. Well, you can see in the bottom left, which is our server, and we can also see it updating in the upper right, which is the other client. And let's move. Yeah, it works. Nice. Okay, let's close this down. Let's see. So beside the double sounds, we have another small thingy. That is, if we are firing, then we are shooting both weapons. So let's take a look at the shooter. Yeah, and in the shooter we also have this part, which has been like a gray area, which I want to remove badly, because I think it's very confusing, this part. When a shooter is tied to an AI, I mean enemy player, then it will also use this one. If the aim target is not, if the aim target is null, then we are local play control. I mean, it's way too difficult. So we are. I really want to change that. So let's do that. First of all, we need to know, do we have a player here? So we can use the is local player. No, so we are going to get a reference to the player. Player, and in our start method, just because we can, or maybe in the awake, it doesn't matter that much. Get a reference to the player, which will be players get component in parent player. Yeah, so now we have the player, so we can use the is local player part. Let's look at the reloader here. Well, if another thing, we don't really want to hassle with the ammunition and counter on our remote players. You know, we just want to fire or don't fire, and we don't want to check the ammo because it doesn't really matter, and it's not a thing to keep in sync. And if we just allow it to shoot whenever it wants, it's fine, you know. So we say if player is local player, then we reload, and we always play the reload sound if the button is clicked. Seems fair enough, I think. Now look here. If player is local player, and we have a reloader, of course. Whoops. Then we are going to do this part. So because then we are only taking ammo from the clip, you know, on a remote player. Or I'm sorry, on a local player, we're going to take ammo from the clip. Maybe at a later stage you could also do this for the server, but now it's kind of easy to hack to have infinite ammo. But just something we can worry about later on. Now let's take this part. I just want to instantiate the look at to an aim target here. Let's see. Let's call aim target to change that to maybe aim point or something. Aim point. Let's make a new vector, new method here, which takes in a vector for to set this aim point. Set aim point vector 3 target, and then we say aim point equals to target. And now let's get rid of this, get rid of this. The look at will always be at the aim point. And we always add the aim target offset, which is for the, this is a transform, vector 3 then. Which is always the offset for maybe for the recoil as well. And then let's see, I'm saying recoil, am I true? Yeah, this changes the aim target offset, you know. So now we say new bullet, instantiate projectile. Then we get rid of this too. And let's move this part where we get the center of the camera. So we simply don't do a look at anymore here, because we are aiming the muzzle, and then we instantiate the bullet. Let's copy this in my cut and paste. Yeah. So now we are gonna use a different way to calculate the center of the screen by calling the new method we just created for the set aim point. And let's see, in the player shoot maybe. Let's get the weapon controller for this to calculate the center of, where we want to shoot. So let's create a new method here in our weapon controller. Here, let's call this public vector 3 get impact point, and then this is where we paste all this stuff. If we don't have anything, we're going to return a vector 3 0. All right. Now, when we shoot our active weapon, so this will be our shooter, I think. Yeah, we have the active weapon is our shooter, so this is in the player shoot. Let's see. We should change the this is one thing we can do. So before we fire, we say active weapon, set aim point, and then we are going to use the get impact point. Yeah, this comes from our base from the weapon controller. So this gets the center and then fires our weapon, the part we just changed here. All right, now we also need to, because we got all this game manager stuff here, which is basically only for we changed this to our states. So do we have a player here? No. Yeah, we have a player. Let's get a reference here. Change this part too. Get component player. Now in the update method, let's see. If player is alive and we are in a pause. Okay, should be fine. Then we can do the weapon switching to only if we are the player is local player. So if we are the local player, we are even allowed to shoot. Move states, printing, return, can fire. Now let's change this to player input state fire 1. And this changes to player input state reload. I think this should do it. Maybe in the update method right here, say if we are not the player, local player, and the player is alive. No, it doesn't. Yeah, and the player is alive. We only want to allow remote players to shoot if they are alive, and otherwise we stop. Then we can create a method here to say if player input state fire 1, if player is local player, active weapon, set aim point, get impact point, and then we say active weapon fire. So if we are not the local player, we are somebody else and we are still alive, and the input state of this player is fire, this will never occur. Let's see. No, we can change the aim point. Let me see. Am I correct here? Yeah, we can remove this. So if we are the local player, we can set the aim point right here. If we are not, not really sure. So let's get back to the player network, and this is where we can set the aim point. Maybe right here we get a solution from where we move. So here is something we can shoot. Maybe we can change this to like server position. Move this out here so we can use it later. And now we get a new factor 3 shooting solution, which is this part, and then we say those new variables here: aim target X, aim target Y, aim target Z. So we need to create these. Like this. And then we set the aim point here. So we get the shooting solution. We set the input controller, we set the input state, and after that we say if shooting solution not equals null, factor 3, 0, because if we don't have a solution we go to factor 3, 0. Probably we should be shooting straight ahead of the current muzzle, but let's keep it for now. So then we say player weapon controller isn't, we don't have any method for it yet. Okay. Let's check it out here. So we create a new one in our player, weapon controller. Yep. So this will get a reference to, let's see, let's show you. If we look at the player, we have the player shoot here, which inherits from the weapon controller, so that way it will find it if we use get component. Okay, so now we have here our player weapon controller set aim point. Oh, active weapon, which would be our shooting solution. Something like this. And now we need to gather the shooting solution. So where we get our inputs, we could say if state fire1. So if we are holding the button in this current state, we get a new shooting solution. Player weapon controller get impact point, and then we say state aim target aim target X equals to shooting solution X, and for those other two, Y and Z. Okay, this should do it. Let's test it out real quick. Oh, I'm having shooters. Yeah, the enemy target, of course. Set aim point. We will now the target transform point position. Fair enough. This should be our target position. No, this won't work, so we need to get a reference here. My target. I really hate these variables, but okay. So we get the distance. Do we have more mistakes here? Can see target should be our target then. My target. And now it compiles, okay. So let's see if it works. The aiming variable is not passing through, it seems. Does it also count for the server? Yeah, doesn't come through, but that's okay for now. Let's see if the impact points come. Now you can see on the scene that that in the lights that it's going completely the wrong way. So it seems that our aiming point is not going where we want it to go. Let's check the. Let's go to single player real quick. Sorry. Just disable the network manager and enable the player. That should get us into single player mode again. There you go. On here, here we have the same problem. So probably the get impact point is not working properly. Yeah, here we go. We are not even returning the method. So what we're doing here, we're getting a ray somewhere in the distance. If we are shooting the sky, nothing will return. So we are returning the hit point now, and instead of returning a vector 0, let's change it right away. Let's make it transforms position, and we add like 50 units or something in front of the player. So if we hit anything except the skybox in 500 units, we aim to the point. Otherwise, we return 50 units ahead. Let's see if this works now again. There we go. And now, instead, it's not going up, but let's keep it for now. Okay, so this should do it for the networking then too. Enable the network manager, disable the player, hit play. Oops. First, of course, hit build. We are hosting here, client. And we are shooting, it seems. There we go. Now you can see right away that we are not syncing the players. I just shut down this target, but it didn't shoot it down on the server. So let's try this one. Again, that's because sometimes it just doesn't completely sync everything. So we obviously need to fix that. Okay, the first thing we're gonna do is mind the player predictions, which we don't have at all right now. Let me show you one more quick example by building it. For instance, if we are, like I said, we are just sending the inputs now to the server. Now, if I go to this client and I just run around a little bit, for instance, like this, in front of the shooting target, which is still in the server scene, and I keep on moving, and now I move sideways, and now we are completely out of sync. Yes, the player on the right is here. Oops. The player here is completely different to what I'm here. So we will need to address that. So let's move to the open up the player networking. Let's close everything except the player networking for now. Just tidying it up a little bit. So we have a server position which we received back from the RPC, but we are not doing anything if we are the local player. We are only doing it if we're not the local player. So what we want to do, we want to have predicted states, which we have created on the client, on the local player. So let's call this a list of network state. Let's call this predicted states. And again, it's not really a prediction. It's like we expect this to happen on the server. So, well, yeah, you can call it a prediction then, I think. So in the start, we instantiate the list. So predicted states equals to a new list of network states. That's the way it works. So we instantiate the list, and now when we move down to the player, where we are in the fixed update, in the fixed update here, after we send it to the server, we simply say state position x equals to transform position x, state position y equals to transform position y, and state for the z and then we add this state to the predicted states. So we add a new item to the state. Now this already has a timestamp when we received it. Let me see, state. When we collect the input, so basically we are expanding the state here, which we create in the update, in the fixed update, with the positions we have, and in the collect input we have a timestamp, yeah, which is also transmitted to the server. So now we have a predicted state. So when it reaches the server, we are not really doing anything with the positions here, just when we get it back. So let's see here, if we go to the update state, we say if we are local player, sorry, and we are not the server, because we don't want to do this on the host. We expect the host to be it doesn't need to correct any predictions. So we don't update any positions or rotations if we are updating the states on the local player, unless the predicted state result differs too much from a server. Yeah. So predicted states. First, we remove all items which we still have, where the timestamp is less than our last received state. So this will, if we have not received everything, because we will miss some, we are unreliable sending the messages, so it could be that we are missing states. So we are removing everything that's older than the one we are now processing. And then we get the predicted state from the collection, from the timestamp, and it should be there actually. So for our predicted state equals to predicted states. If you don't have the let's see what happens. You can see we don't have the where clause, so if you press Shift Alt F10, you can insert the user statement for the link, and then we say where x timestamp equals to last received state timestamp, and we take the first one. We expect it to be there. We expect the state to be there. Remove the old states, if there are any. Now we compare the outcome of the predicted state to the one we got from the server. So predicted position equals to a new factor 3, and then we put in the predicted states, predicted state x, predicted states transfer position x, y, z. So now we got the predicted solution, and then we can compare the position difference from server equals to a factor 3 distance, and then we take the predicted state position and we compare this to the server position. Now if the position is greater than, let's say, 0.3, we set the position to lerp to that position. So this will continue on until we are back at position where the player should be, and we take the player settings run speed again times time delta time. So it's pretty much the same which we are doing here for the remote clients, but now we are doing it for our own player. Let's see, I think we can move these here too, because we don't need to animate what we receive from the server if we are the local player. Well, let's see what happens. client. Yeah, we are still animating, so that works. But now let's try to shoot something that only happens here. You can see it from time to time now. There we go. So this one is out of sync right now. No, it's not. Which one? This is. So now I'm pressing forward, but it won't run on the client anymore because it will try to keep in sync with the server. Now you notice that sometimes you have some small hiccups, like you see right here, and well, you should try to hide that even better. But I think sometimes it's a little bit too much. But it works, I think. Sometimes with small corrections, you can still feel it. It's correcting too much, or maybe we should increase the position difference, or maybe decrease it. But you just have to play around with that until it really suits. So that's it for this video. I hope you learned something from it, and I think we made a good start with our networking. If you like this video, please subscribe to my channel and like this video, so maybe others just like you will be able to find this series more easy. Thank you very much, and I'll see you in the next one. Take care.